Hello AP Physics students, it's Mr. Kennedy again. Hope everybody's doing well. This little video here today is going to be your first mechanics review. It's been a long time, but it's time to start getting ready for mechanics as you get ready for that part of the AP test as well. And we're going to take a look at two units today. We're going to take a look at units 1 and 2. That's motion and then forces. And what are the big ideas that are going to be involved with them. And you know, this is not going to be everything you could possibly need, but it's going to be the main ideas. So let's take a look at unit 1. What are some of the main things here? And then we'll jump into unit 2 after that. So unit number 1 was really all about motion. And the fact that you now have so much more experience with calculus is going to make this part of it seem really basic from when we started at the beginning. But let's go back really far. One of the first things you did in honors physics last year was you took a look at things that moved with some kind of constant velocity. When things moved at constant velocity, they just obeyed this equation, that the displacement was equal to velocity times time. And even though you're involved in AP physics, you're still going to have some things that move at constant velocity, and we'll see a quick idea for that in a minute. But then after that, we looked at 4 equations of constant acceleration when things sped up or slowed down, etc. And those were v equals at plus v naught, x minus x naught equals v plus v naught over 2 times time, x minus x naught equals v naught t plus 1/2 at squared. And then v squared equals v naught squared plus 2a x minus x naught. So this equation is just for your basic constant velocity. These are your equations of constant acceleration. Now, in projectile motion, what you're going to use is both of these. In projectile motion, you'll see that things that are moving in the horizontal way will use this as the motion, where the vertical motion is described by these 4 equations. So it's very common for them to ask you questions of projectile motions, because that way they can get in a question that has acceleration in it and to have horizontal motion at constant velocity at the same time. Now, my advice to you when doing projectiles too is make the acceleration, instead of make it 9.8, make it 10. Make this easy on yourself, especially when you're dealing with some multiple choice questions or even on the free response. They'll accept 10, so just go ahead with it. But this stuff is probably what you would consider to be very basic. My challenge to you now is to try to make it a little bit faster. Think about what you may be doing in terms of graphing. And in terms of graphing, we'll take a look at the calculus stuff here in a minute. But in terms of graphing, make sure you're able to move from one graph to another. So, but these are some basic things you should know. Now, in terms of what happens with the calculus, really what's happening is, if you want to go from position to velocity to acceleration, you are taking the derivative. If you're going from acceleration to velocity to position, then you're taking the integral. And you can go past here if you want. You can go to jerk and yank and all the rest of that stuff. But these are the basic ones you're going to have to know, is taking the derivative and the integral. And again, this is probably going to be so straightforward at this point because you've done so much in terms of calculus. But just as a quick idea to remind you, if I were to take something simple like this, if I were to take 3 different graphs, and this is position versus time, this is velocity versus time, and this is acceleration versus time. Just to give you a quick reminder of how things work, if I want to move from this graph to this graph, in other words, I want to ask myself, what is this thing doing? It starts out with a velocity of 0, a slope of 0, so this is a position of 0. Then it has a positive velocity, so this is a positive number. And then it has a more positive velocity, this is a more positive number. The slope of this graph tells you about this graph. Then the slope of this graph is positive. So because that has a positive slope, this is a positive number that never changes. The slope, which is the derivative, tells you about what happens in the next graph. But then if you want to think backwards, what happens if I move from acceleration to velocity to position? The area underneath this graph tells me how much this changed. So this area tells me that it went from here to here. That's how much it increased. The area under this graph tells me how much this increased, how much that changed. So these graphs are actually a way that you can solve problems. And if you solve the problems by the graphs, you can sometimes avoid the equations even though you're really using the equations together. So again, be very, very familiar with how to use the graphs. Even if there's something simple like constant velocity, make sure you know how to do it. And it's just a matter of practice. Usually these are time-saving questions that you can do on the AP test because you can do them in your head. So I would make sure to do as much practice as possible with this. The second unit, which is one that just kept having things that could come out of it, was forces, because there were so many things you can do with it. And it really comes down to three basic rules, Newton's three laws, and then some applications of it. Law number one was if the unbalanced force on an object is zero, then the velocity is constant. We tend to say that as objects at rest tend to stay at rest, objects in motion tend to stay in motion, but if the forces are balanced, the object is moving at a constant velocity, and that should be constant. The acceleration is zero. So the velocity is constant, the acceleration is just zero. Now the velocity could be zero, but doesn't have to be. So again, if the forces are balanced, the object moves at constant velocity, the acceleration is zero. If the object has unbalanced forces on it, then the unbalanced force must be equal to ma. The bigger the mass of an object, the less it's going to accelerate. The bigger force, the more it will accelerate. This is your bread and butter type equation that happens on here. And then the third, which is something that shows up all over the place, even on the electricity test, they'll ask questions about this, is that the force of one object on another is the opposite, equal and opposite, to the negative of the second object on the first. So this is your action-reaction law. And oftentimes they'll ask you questions about this that are really not seeming like they're asking about action-reaction, but they'll say, what's one planet pulling out? A planet is pulling on a moon. What is the force that the moon pulls on the planet, etc.? They're really asking you about action-reaction. But in all of this, in everything you do, I cannot stress enough that you should do a force diagram. On the AP test, they'll often give you points for force diagrams, and that's actually a point that's helping, or points for helping you solve the problem. People that skip the force diagram usually do not do very well. Draw the force diagram out. It gives you clues on how to solve the problem, so I would make sure to do this. And you can use tick marks, etc. You can break things up, but absolutely make sure you do it. Helps you write equations, helps you figure out what's unbalanced, etc. But this is a key thing to make sure you do the force diagram. So, one extra thing that came up with forces is what happens if you have an unbalanced force that has something move in a circle? That's a special case. If you have a special force where things move in a circle, there's really no difference. It's just the acceleration is different. So if something were to cause an object to move in a circle, then the unbalanced force is still equal to ma. It's just a is v squared over r. That's the centripetal acceleration. So you still should do a force diagram. You still should do a force diagram, find the force or combination of forces that points to the center of the circle, and then that force that unbalanced force should still equal ma. So the rules still apply, and they still do. But one situation that I want you to practice and be prepared for, and it's actually one of the practice problems that I'm going to give you here in just a minute, is what happens if you have a situation where an object experiences a force that is proportional to its velocity. And one of the most common examples is air resistance. For instance, let's say we drop an object. Here's the object here, and as we drop it, it experiences a force mg down. In other words, there's a force of gravity that points down. And then there's another force, that's the air resistive force. Let's just say it's kmv back the other direction. So this is a challenging problem because the acceleration is not constant. As a matter of fact, it's eventually going to balance out, that these two forces will balance. It'll go to terminal velocity, and that's one of the big things there. But the point of a problem like this is you still have to go back to the beginning and still have to do the force diagram. And here it is right here. It has a bigger force down, at least in the beginning, and then it has this force back. So the unbalanced force, which equals ma. Unbalanced force here is mg minus kmv equals ma. The masses cancel, and what we'd like to find out of this whole thing is what's the velocity as a function of time. But this is the beginning steps of it. You are not going to be able to algebra your way out of this thing. You're going to have to use some calculus. And the big step that you'll have to use here, or in any of these situations, is you're going to have to realize that A is dv dt. If you don't do this, there's no way you can unlock this problem. And when we look at it, g minus kv equals dv dt, this is messy. It really is. But what we're going to try to do is get everything with t on one side, everything with v on the other side. So we get dt equals dv over g minus kv. And when we first looked at this, this was a very daunting problem. But now, this should be a little bit easier now that your calculus skills are much better. We're going to integrate from 0 to t. We're going to say we dropped the ball, so this would be the initial velocity here is 0, and the final velocity is just v. Oddly enough, the thing we're looking for here is right here. This is this final velocity. That's what we're looking for. But again, you proceed the same way. You have to start with a force diagram, figure out the unbalanced force, set it equal to ma. If you don't do this dv dt, you're not going to be able to get to this integral step here. And from here, you can solve the rest of this on your own now, because now you're much better at calculus. You realize that this is a u substitution, and then eventually you'll solve for dt. My advice to you, though, is not to actually use any of the plus c stuff that you've learned in calculus. I would put in what the actual values are in the beginning and the end, and make sure you plug them in at that case. So what I would do, I would try seeing if you can solve this this remaining part and see if you can get it back to velocity as a function of time, and see if you can make sure to do it. The actual answer is v equals g over k 1 minus e to the negative kt. And it should work out pretty well that you see that g over k is actually the terminal velocity if we went back up here when the acceleration was 0. But this is a problem we did a long time ago. I would take a look at it, make sure you're able to do it. I always tell students to expect it's on the AP test. Always expect the hardest things to be on there. But so that's a basic review of motion and forces, and a little bit of extended thing on some air resistance and how to solve it by breaking the A's dv dt. I would now take a look at mechanics year 2000, number 2. I put it on my calendar. Try that one out. And obviously, as always, feel free to ask questions. Let me know what you're having a hard time with as we're trying to get ready for the AP test. But hope everybody's having a great day, and I hope to hear from you with any questions that you have.